Hello, this is Chapter 14, Lesson 2. Lesson 1 left off with thrust bearings. So thrust bearings are bearings that can resist only thrust loads. Those are loads parallel to the axis of the shaft. They can take little or no radial loads. And then here are pictures of your typical thrust type bearings. Next type of bearing I want to talk about is mounted bearings. And really, mounted bearings are sometimes called pillow blocks, but they have a means of attaching the bearing directly to the frame of the machine with bolts. Some are flange units, some are what we call pillow blocks. That's the most common configuration for a mounted bearing. They're simple for machine designers to apply. So here's a typical picture of a ball bearing pillow block. Okay, in this case, the shaft will be inserted right here through the bearing, and then you can bolt this pillow block, right to the frame of your machine. So it's very handy for a machine designer. I'm not really going to talk too much about bearing materials, other than they have to be very hard to prevent wear and then damage or any yielding. So bearing materials tend to be very hard and very strong. Okay, so this gets into what your assignment is for chapter 14, and this is about the load-life relationship. Okay, so all bearings have a finite life. All bearings are not going to last forever. Eventually, bearings are going to fail due to fatigue because of the high contact stresses. And in a roller bearing, that's the contact stresses between the balls and the races, like I showed you in the first picture. The lighter the load, and again, I'm going to be focusing on radial loads for this discussion. We're really not going to get into thrust loading, but we're going to talk primarily about radial loads because it's the easiest one to discuss at this point. But the lighter the load, the longer your bearing is going to last, and vice versa. And then equation 14.1 I'm showing you here describes the relationship between the bearing load and the bearing life. Okay, so those lives, L1 and L2, those are generally designated in terms of number of revolutions before failure. And then P1 and P2, those are the radial loads. If you're talking about ball bearings, the K exponent is going to be 3. And then we're going to talk about two examples of problems in separate lessons. Okay, so then these are the equations we're going to be using in those examples. Those examples also get into talking about what bearing manufacturing data is. The manufacturers will all publish data that talks about what the life of their bearings are based on the loads. And then typically within any one given size of a bearing, a manufacturer will have at least 3 classes, an extra light, a medium, or a heavy class. And then each one of those comes with a different load rating. And those are shown in table 14.3, and we're going to discuss this table a little bit more when we get into the examples. Design life. Design life is specified by the designer considering the application. And I'll have a second example problem too I'm going to walk you through to talk about that. That also gets into this table 14.4. We're going to discuss this more in example problem 2. Now I included this slide right here just to talk about how bearing life is designated. Okay, so bearing life is designated primarily through a statistical process. So bearing manufacturers will run lots of data and determine when or where, at what point their bearings are going to fail. And typically the life is reported in a bearing manufacturer's catalog as 1 million revolutions. And then usually it's designated as an L10 life. And what L10 means is that out of a population of a bunch of bearings, 10% of them will fail before they get to the 1 million cycles. And then 90% of those bearings will last the whole 1 million cycles. And again, we're going to talk more about that in the example problems. That's the end of this lesson.